Alright, we're going to continue our review of the Oblique surfaces review, and we're going to start with the solving the oblique problems with a given true length line, right? And don't forget your true length line is going to become a pointer line, yeah? We're going to project in a direction indicated by the orientation, yeah, of the true length line. And then you're going to do your projection parallel to that true length line, yeah? Remember the previous program we did on a planar surface is going to give you the edge view, the primary auxiliary. And then the true size and shape of a planar surface is going to result from a perpendicular projection, yeah, from that edge view. Just recalling what we did, okay? So let's take a look at this. So you have two views, yeah? Your front and then your right. And we have to solve the problem of your true size and shape, yeah? So we get the third one. We're dealing with the triangle. First, we're going to verify the projection. Do the same thing. How do we verify the projection? We are going to project from the points, 2 points, yeah, corresponding points between the two views. And then we will insert the full line, yeah? So let's do that. We're going to label all the points. We have our projectors, 1, 2, 3, corresponding points, 3 to 3, 2 to 2, 1 to 1. Throw your full line, yeah, perpendicular to the projector line, all of them, yeah. That's the first thing you do. Look for the parallel, yeah, line to your full line. This is the only one that is parallel, yeah, see that, yeah. Projected, yes, from that line to the other side. So 1 and 3, 1 and 3, and this is your true length, your TL, all right, is there. Yep. So we're going to base that TL, right, which is your true length, to get the next projection, yeah? So we already know this, okay? So you see that how we draw and identify it. All right, this is a single line. The next one, we're going to start, okay, from this true length line and get our edge line, yeah, which is your edge view on from this side. Okay, it's going to come out. So you gotta think about whether you're gonna draw, even if we're trying to get the top view, because you're given the front, right, and then the right side view. So you gotta think about, whether you're gonna put that, since this is a front, right, view, and your parallel line is on this side, we're getting the true length on that side. So therefore, we'll have to project it from this side and to the top view, yeah? So I would just go this direction, okay, to get our next edge view. So let's take a look at how they do. Yeah, the same thing. So now we're gonna project it, yeah? Project a line. 3 and 1 is on the same line, so therefore you get a point. Your 2 is there, okay? Make sure you keep your distances, okay? We're gonna throw the second full line right there, all right? And we will draw our edge line on this side, okay? Now I got my edge line, 1 and 3, got to be the same distance because it is 1 and 3 and then 2. Okay, 1 and 3 is fused together because they are on the same line. And then you have 2. So the distance between 1, 3, and 2 is the same as the distance between 1 and 2. So we're going to keep that, yeah? And don't forget why your 2 ended up right here is the distance, yeah, between this full line to 2, okay? The distance, yeah, full line, all right, to 2, and that distance gotta be kept, all right? Okay. We're gonna put the full line close to there. Full line can go anywhere in between the two views, all right? So don't worry about moving from here to there. You can do that. So now we're going to get rid of it closer to the middle view. Yeah. And now let's start projecting 2 and then 1, 3, okay, to our third full line. Why do we need a third full line? Because we need to project, yeah, our top view from this edge line, okay? You can do it directly, so therefore we have to go with the edge view first, because you're dealing with a true line, because you have a parallel line, yeah, to your first full line. Okay, so throw the third full line right in there. And we're going to keep our distance the same thing. 2 gotta go 2, okay? 1 gotta go to 1, and 3 gotta go to 3. The distance is going to be, yes, 1 and 3 gotta keep this distance. 2 and 3 gotta keep that distance, yeah? And 1 and 2 gotta keep this distance. So how do we come up with that? Because of how we place our second full line at the edge of our middle view, see? So since we put the edge, we're gonna throw this, yes, full line, and we're gonna start from the point 1 like this. So your distance, yeah, from the full line to 2 got to be the same. Your distance from the full line to 3, okay, got to be the same. And 3 and 1 are on the same line, so it solved the problem. Your distance to 1 is at the full line, see, because we started out that way, but it's easier for us to draw that way. Okay, that's my chair is moving, sorry. And so anyway, you're gonna have a little bit of issue, okay, how to transfer from edge line to there, and that greatly depends on where you place your full line, because your distances got to be measured from the second full line, all right, your middle view, and we will clone it, of course, from the third full line to the last view we want, which is the top view for this case. Now we're going to get rid of all of our drawing stuff, yeah? So we have a nice and neat little projections right here, yeah? And that's our top view. We keep the true size and shape, of course. Alright, so that's the end of your true length line, given true length line, and I'll get the third view, yeah, veer and edge view, yeah, projected from your true length, and your true length came from your parallel line to the first full line. Alright, that's it for this section.